All right, hello. Thank you for taking your time and watching my presentation here. And I'm Luke. And today I'm going to talk about random idiots. Yeah, exciting. And it is actually a neural network ensemble. So let's get started. So for this presentation, I'm going to walk through the develop of this algorithm, how I thought about it, and how I actually testing it, and the results, and also discuss how well it actually works. So to begin with, I'm going to briefly talk about the ensembles and the random forest. So I copy and pasted the definition of ensembles learning and random forest from Wikipedia, of course. Yeah, because everything they say is correct, right? And all right, and yeah, if you want more information, you can go there and take a look. I'm not going to extensively explain them, but yeah, let's just start with bazillion of mathematical formulas and equations, like all the Wikipedia pages and academic papers. All right, so anyway, let's see. We all know decision trees, right? And it's like this very nice grown tree here on the left. We're trying to build as much branches as we want with the features and trying to get a really good classification models. But the random forest actually take another approach. It's actually training all those really shady looking trees with not very much, not a lot of branches, and it actually worked really well. It's actually one of the best classification algorithms out there. So it's kind of inspired by this. You know, instead of have this one smart guy, I'm just going to have a lot of kids to help me to classify. All right, so let's see how it actually works, right? So I'm trying to solve those four problems, right? And Terrence here is helping me. This very smart guy, the star, is trying to help me solving all those four. Alternatively, what we can do is we can have the four idiots. The first guy is Paris. Oh, I thought that's a city's name, but anyway. And then we have Justin. Oh, sorry, that was Justin's phone. I'm just telling him to shut it off. Oh, and we have L'Angelo. And then finally we have Donnie. And we just assign all those tasks to them and see how they end up with them. And if they works well for one of the subjects, then we just give them this chance. And this gives us several benefits because if we have four people now, and so it's faster for them to learn each one of the subjects. And another benefit is, what if Terrence is not very good at arts? So this also gives us some perks here. So let's see how it actually implemented. So I'm just trying to train like 50 neural networks and with different numbers of hidden layers and different numbers of nodes, and we call them idiots. And because they are shallowly trained, mostly they are only using part of the data and trained for only one epoch. And then we're going to combine their classification results. So the very obvious one was using a majority vote, and there are also like linear regressions and other classification methods that we can use to combine them as part of the ensemble learnings. So first, let's take a look at the majority vote. Okay, so here is a random idiots model with 50 idiots and a train split up 10%, which means only 10% of the training data are used to train each one of the idiots, and I'm only training them for one epoch. And it turns out to have a average accuracy of 0.75% among the idiots and 88% accuracy for the max accuracy for the idiots. And if I use the ensemble and taking the majority vote, it ends up with 87% accuracy. It's not ideal, but you know, we can live with it. And what if we're using linear regression? It actually doesn't really work very well because the MNIST data, although it has the label as 0 and 1, 2, 3, 4, it's actually not, it doesn't really have that numeric relationship. So it's not really a regression problem. So our best bet are at those classification methods. And not surprisingly, random forest works the best, and they actually perform much better than the maximum random idiots class of models in our ensemble. So which is what we are really trying to look for. And if we look at the average of all the models I trained, random forest still works the best. But here, if we look at the very shallowly trained random idiots, it seems like if we train them for only one epoch, the random forest always works really well. But if we actually train them more, let's say like 5 epoch, it's that kind of backfired. All ensembles doesn't really work as well as just trying to find the best idiots in all the idiots, right? So I'll explain why this is actually happening. Another thing is what about different numbers of idiots, right? So if we have 100 different idiots instead of 50, actually it does kind of increase the accuracy, but I can't really go more high. My computer just can't handle that. All right, so let's say why it actually works and why it doesn't, right? So I create this visualization here. So the yellow parts are the ones that are correct. Models are created correctly predicted. If they are dark, they are wrong. So each row is a model, and each column is a case. So here we can see how this ensemble works, right? So let's take a look at those models and those models. Okay, we can see this part of the for those models doesn't work really well, but for this part they actually works. But for those models here, they works really well. So if we combine the results of those two models, they can actually create this part perfectly, and this is how ensembles works. But let's see, here is the problem. It seems like for all those cases, none of the idiots can correctly predicted them. So no matter how I combine the results of all those ensembles, those are always going to be wrong. So I guess it just doesn't work really well here. And what if we train them really well? So like say, let's just extensively train all the idiots. It seems like it's always going to have this band of incorrectly predicting cases for all the idiots. And I guess, let's talk. So I have to talk about the nature of the neural network. It seems like no matter how I try to train the model, to create a model, like with different node, different hidden layers, and even different initial weight distribution, the model is always going to be trained towards the same classification boundary. So I guess neural network is just not a very good base learner for bagging algorithms. All right, so what else we can do for if we really want to build a neural network ensemble? So one thing we can do is boosting. Okay, but I don't really want to try because it really defeats the purpose of what I'm trying to achieve here. Because if we are bagging the neural network, it will be very fast because we can train them in parallel, and we can train if we need like 500 different idiots, we can just using 500 computers and train them at the same time. And instead of training a deep neural network, which takes a long time, and the boosting actually, it's kind of like training a deep neural network, and you can't parallelize them, and they also going to take a long time to train. So I don't really want to try it. And then some other things will be like stacking and boosting or bagging. So what else we can do, right? So let's see if we want to, let's just change this completely to random forest. Okay, let's adding feature sampling, sampling different pixels from the picture. And then we use neural network classifier as a combination method. Okay, then we call them random vision impaired idiots. So What are they? Sorry, they are just convolutional neural networks, right? This convolutional neural network has this convolutional layers trying to sample all those parts of the pictures and then train a bunch of different models, the feature maps, and then you combine all their results with a fully connected layer, which is neural network classifiers. So I guess I just find out how they invented CNN, maybe. So that's just kind of frustrating. And I guess this really explained why CNN works really well, right? It just works like random forest. So, although thank you again for listening to this presentation. Although it doesn't work really well, but uh, thank you again. But spending all those times, and hope you have a really good holiday. Thank you.